Hi, everyone, and welcome to this next installment of Precalculus. We're still in Chapter P, so we're covering a lot of the different algebraic topics that you would have seen in college algebra that we're going to need to use throughout the Precalculus course. We're going to cover one of the two most important things that we're going to see in this prereq chapter, and that's factoring. The other one will be solving equations, which I'll do in my next video. But the focus of this video, the topic of this video is factoring. And I'll have the definition, sort of the dictionary definition of the word factor. Now, factor, there's the noun and there's the verb. Right? There's the object and the action. This is the action of factoring, right? To factor something is to decompose or break it apart. For example, a number, polynomial, into the product of other objects or factors, which when multiplied together give you the original object. Now, the reason we're saying object, not number, is because it doesn't have to necessarily be a number, but we could start off with a quick example. Let's say, for example, the problem is to factor the number 18, factor 18. Well, decompose or break apart the number 18 into other numbers. In this case, the objects are numbers that multiply together to give you 18. So, for example, 2 times 9. Right? I have just factored the number 18. I've broken it apart into the product multiplication, not addition, subtraction, but the product of two other objects. Okay? We could factor 18 differently. We could say 18 is equal to 3 times 6. 3 times 6. That works also. It doesn't really look like a 6. It looks like a B. 3 times 6. Okay, neither one of these, though. These are both factorizations of the number 18. We have factored 18, but neither one of these is actually factored completely. So if I add the word completely to the direction, so factor completely, we would have to go a step further. Because with the number 2, we can't break that down into smaller numbers, but the 9 we can. So 9 is equal to 3 times 3. So to factor completely, we would need to say 2 times 3 times 3. So the important thing here is, one, factoring doesn't always happen in one step. You'll see that in this worksheet, in these problems that I'm about to work through and explain. Factoring doesn't always happen in one step. And two, when you break a number down into factors, you may get something times something, or you may get more than 2 factors. In this case, 2 times 3 times 3. If we start 18 equals 3 times 6, we end up with the same thing because 6 is 2 times 3. The order doesn't matter. We have a pair of 3s and a 2. All right, so this would be what we would call factored completely. We can't break down the number 2. We can't break down the number 3 any further. So we're done. Now, I want to talk about some different ways of factoring. And it depends on the problem. So factoring is a tough one because there's a lot of variation. And when you look at the problem initially, you have to decide which approach I'm going to take. Right? The first one, pulling out a common factor. Right? We're going to call this plan A. Right? Pulling out a common factor is plan A. So the first and second problem that I do, I'm gonna look at pulling out a common factor and then go from there. Plan B is the rest. Right? We'll call this. Let me go back. Plan B. All right. So what I mean here is any problem where you have to factor. So in this section, the topic is factoring. So the whole problem is just a factor. Next, when we're solving equations, factoring is going to be the first step in a longer problem. It's a very important tool to have in our toolbox. So anytime we're trying to factor, the very first thing always we try to do is find something common, find a common factor to each term. And then if that doesn't apply, then we'll look at these other methods, factoring by grouping, factoring quadratic expressions by guess and check, factoring quadratic expressions. I'm going to talk about what I call the AC method. And then there's special factoring formulas, difference of squares, sum of cubes, difference of cubes. We'll get to all of these, but those are all plan B. Plan A is pulling out a common factor. So let's look at number 1. Factor the following polynomial expression. In this case, we're using the greatest common factor method. What we're looking for, now before I start writing, what we're looking for is something, right? Some factors that are common to each term. So this is the first term. This is the second term. Remember, terms are expressions that are separated by plus signs and minus signs. So we have a 4x squared, that's the first term, minus the 8x, which is the second term. So now in each of these terms, we're looking for something that is a factor, but it has to be a factor in each term. So we have the number 4, the number 8. Both of those numbers are divisible by 4, or have a 4 as a factor. 4 is 1 times 4, 8 is 2 times 4. So 4 is common. Next, there's x squared in the first term and x in the second, so there's at least one x in each term. There's at least one x in each term. So that first term is 4x times x. That second term, I'm going to use red for the common factor, is 4x times 2. All right, 4x times x is the first term, 4x times 2 is the second term. I'm writing it out like this. You don't necessarily have to show this step, but I'm just using this as a visual demonstration. We're looking for the same copy in each term. There's a 4x in the first term, there's a 4x inside the second term. So that common factor comes out front. And the leftovers from the first term, there's an x, then there's a minus sign, and then there's a 2. Okay, so what are we doing here? When I say pull it out, what does that mean? Why are we allowed to pull it out? Well, what we're doing is it's the reverse of multiplication. So one way to think about factoring is, now this word may sound a little strange, but it's unmultiplying. Right? Factoring is unmultiplying, or the reverse of multiplying. So it's the reverse of the distributive rule. If I were to say at this bottom step here, the 4x parentheses x minus 2, if I said multiply, you would multiply 4x times x, and you would multiply 4x times 2, and you would get the original problem, 4x squared minus 8x. Factoring is doing the exact opposite of multiplication. Factoring is doing the exact opposite of multiplication. So our final answer, 4x parentheses x minus 2. Next problem is another example, same type. Pulling out a common factor. In this case, the common factor was 4x. In number 2, we have 2 terms here, right? The first term let's write this here. The first term is x times x plus 5. right? Has two factors. It's the x multiplied by the parentheses x plus 5. So there's two factors there, but that's the first term. And the 3 times x plus 5, that's the second term. So we have two terms here, and these two terms have something in common. They both contain an x plus 5. Right? They both contain an x plus 5. So that's the common factor, x plus 5. So again, I'm using some informal language here, but when you're factoring out a common factor, a greatest common factor, it's always going to be equal to the common factor. Ooh, keep skipping ahead here. The common factor multiplied by the leftovers, right? If that makes sense. The common factor in this case is x plus 5. So we're taking the x plus 5 from the first term, and the leftover there is an x, right? The x plus 5 came out, we're left with the x. Second term, the x plus 5 came out, and we're left with a 3. Right, so that would be our final answer for this one, x plus 5 multiplied by x plus 3. Okay, this particular problem is going to be important later on when we're factoring quadratics, because we're going to come across things that look exactly like this as a step in another problem. So this one's important for later on. Okay. The next method, and I'm going back on that list from the very first slide. The next one on the list, factoring by grouping. When do we use grouping? Well, when we have 4 terms, right? So if you look at the step-by-step directions over here on the right, start with 4 terms. It's not a step that you're actually doing, but start with 4 terms. That's step 1. You have to have 4 terms. You're not always going to be able to factor by grouping, but if you're going to, it has to be with 4 terms. The next step, group the first 2 terms. Ooh, that's too big. Group the first 2 terms and the last 2 terms. Now be careful if the middle sign is a minus. In this case, it's not. But if this middle sign is a minus, as soon as you put up parentheses, then you have to distribute the minus sign. So just keep that in mind. Make sure any change you make, each step is still equal to the original problem. If the 10 is negative in the original problem, it has to remain negative in the next step. Okay, then we're going to do what we did in the first couple of slides. Pull out a common factor, right? So this is not a completely separate method. This is not a completely separate method. So in this method, we start by grouping, and then we apply the method of pulling out a common factor. So what we're doing here is, rather than looking at the whole problem, all 4 terms, we're looking only at the first 2. So what we could do basically is ignore those last two terms. All right, we could do that. Ignore the last two terms. So step 3, factor the first two terms by pulling out a common factor. So what's common between x cubed and 2x squared? Well, each of those two terms have two x's, at least two x's. So there's two x's in common. So we could factor out an x squared. And the leftovers would be, there's an x, because x squared times x would be x cubed, minus, from the 2x squared, if we take out the x squared, we're left with a 2. Okay, then there's a plus sign. So start with 4 terms, group the first two, group the second two, factor the first two terms by pulling out a common factor, and then let's erase that. And now factor the last two terms. So now you could ignore, you don't literally have to cross it out, but you're only looking at the problem half at a time. First, you factor the first half, then you factor the second half. So 5x and a 10. Well, they don't have any x's in common, but both of those numbers contain a 5. 5 is 5 times 1, 10 is 5 times 2. So there's a common 5 there. And what's left from the first term would be x. And what's left from the second term there would be 2. Okay, so factoring by grouping means you're pulling out a common factor actually 3 times. We just did it twice. And then step 5 says, now there are 2 terms, factor a 3rd time by pulling out a common factor. I'm going to go back to the second slide. Now it's looking exactly like this problem, right? 2 terms, and there was a binomial, this x plus 5 common to each of those 2 terms. So now we're in exactly the same place. We've got an x plus 2 in the first term. We've got the same x plus 2 in the second term, so that's a common factor. So we'll pull out an x, not plus, x minus 2. We'll pull out an x minus 2. That is our common factor, and then the leftovers. What's left? From the first term, we're left with an x squared. And from the second term, we're left with a 5. All right, so that would be our final answer. X minus 2 doesn't factor. We can't break that down anymore. And x squared plus 5, that also doesn't factor. We can't break that down anymore. All right, so that does it for factoring by grouping. Now I'm doing these problems in a very specific order. Pulling out a common factor first, because we use that in the factoring by grouping method. Factoring by grouping second, because I'm going to use this next in the factor and quadratic methods. So we're sort of building, each problem is building on the previous problem. The next 2 problems. Number 4, x squared plus 5x plus 6. And number 5, 9x squared minus 9x plus 2. These are 2 examples of quadratic equations. Not equations, sorry, expressions. Quadratic expressions. So a quadratic expression is a degree 2 polynomial. Oops, didn't want red, sorry. A degree 2 polynomial. Let's see if I can get this right. Yeah. So the highest power of x is 2. Right? There's no x cubed, there's no x to the 4th. It's just x squared is the highest power. So this problem, x squared plus 5x plus 6, that is a degree 2 polynomial or a quadratic expression. So let me write this. Next to this, the definition, x squared, ax squared plus bx plus c. I'll write quadratic. Right? The a, the b, and the c are numbers. They could be any numbers. In this case, the a is equal to 1 because it's 1x squared. The b is equal to 5 because we have 5x, and the c is 6. The only restriction is that a can't be 0, or else if the a is a 0, then the x squared disappears because it's 0 times x squared. So b and c could be any number, positives, negatives, fractions, decimals, square roots, and any real number. The a could be any real number as well, except 0. Now, quadratic expressions will often factor like this. So if a, b, and c, if all of those are present, right, if they're all present, meaning none of them are 0, if none of these guys are 0, like in this case, we have a 1, a 5, and a 6. In the next problem, a is 9, b is -9, and c is 2. We'll get to that one in a couple of moments. If the a, the b, and the c are all present in the problem, meaning none of them are 0, then it's going to factor apologies, I'm trying to get this pen right. Let's see if I could get it right on my third try. There we go. Yes, it's going to factor to look like this. Product of two binomials. Now we've seen this before. We've gone in the other direction. We've multiplied these binomials before. You may remember, hopefully you remember, if you're starting with the right-hand side, what I have highlighted in yellow, let me get rid of this arrow, too many arrows. We multiply, and sometimes we use what's called the FOIL method. First times first, outer times outer, inner times inner, and last times last. And what we're doing is doing the opposite. We're factoring. Uh-oh. Okay, we're back in business. So we're factoring, which is the reverse of multiplying. Right? Foiling, we say the FOIL method. That is how we multiply. I covered that on a previous video about a previous section. So how do we do this? Well, there's two methods I'm going to use. The first one is just guessing. Now, guess and check, or we could say trial and error. It's a perfectly legitimate mathematical approach to solving problems. So in this first problem, I'm going to be using guess and check. Now, it's not random guess. It's not guess anything and then, see if it's right or see if it's wrong. It's actually the educated guess and check method. You want to make an educated guess or an intelligent guess, something that might be an answer, and then check it. So if we look at what I have here on the bottom where it says factoring and FOIL, right? If we know what the answer should look like, so x squared plus 5x plus 6. When we factor this, it should be something plus something times something plus something, right? I'm going to write it actually below because it's getting a little crowded over there. So this should equal something plus something times something plus something, right? Now, FOIL, first, outer, inner, last. So first times first has to give us x squared. The only way to get an x squared is by multiplying x times x. Right? First times first equals x squared. And last times last has to equal 6. I'm going to write this actually twice. The reason I'm writing it twice is because there are two ways to get the number 6, right? What is 6 equal to if you factor it? And this is the very first thing I did when I factored the number 18. A number could be factored multiple ways, right? So 6, there's two ways we can multiply two numbers and get a 6. It's 6 times 1 or 3 times 2. Right? So which one of these is the right answer? First times first equals x squared. So first times first, first times first, check. The F in the FOIL works out. Last times last. 6 times 1 equals 6. 3 times 2 equals 6. Check. The L works out. The F and the L, the first and the last work out. But now outer and inner. Right? So if we multiply outer times outer, and then inner times inner. So in this case, outer times outer is x times 1, which is x. Inner times inner is 6 times x, which is 6x. In the other option, if we do outer times outer, that's a 2x. And inner times inner, 3 times x, that's a 3x. But we're trying to make the original problem, which is x squared plus 5x plus 6, meaning we have to make a 5x. Outer times outer, inner times inner has to give us a 5x, and it looks like the one on the right. The 3x and the 2x will give us 5x. So we're trying to figure out two numbers that multiply to give you the C, right? But then add up to give you the B term. Right? In this case, there's only, like, for guess and check, you don't want there to be too many options. Some problems there'll be 12 or 15 or 20 different options. Here there's only 2, because we know x times x equals x. There's no wiggle room there, but there's 2 ways to make the number 6. 6 times 1 or 3 times 2. So I'm going to write the answer down here on the bottom right. Let's say we know this is the way. If we were to multiply this out, we would get an x squared plus a 3x plus a 2x, which would give us the 5x plus a 6. So x plus 3 times x plus 2. So the guess and check method is nice when there's no number in front of the x squared, when the coefficient on the x squared is 1, or when the a is equal to 1, because that means there's not too many options that we have to check. In the next problem, 9x squared minus 9x plus 2. Well, now there's now there's some more options here. There's actually like 8. If we were to use guess and check method, there'd be about 8 different possible answers, and you don't want to check all 8. You definitely don't want to check all 8. So we're going to take a slightly different approach. I'm going to go back a couple of slides. Factoring by grouping. Right? This is just 2 lines here. There's not much work involved. So factoring by grouping is a bit more straightforward in terms of factoring. So what we're going to do with what's called the AC method is to take a quadratic problem and turn it into factoring by grouping. So if you understand grouping, this should be no problem. So what we want to do is step 1. We're focused. We're focused right here. We're focused on that middle term. We want to split this up, like to 2 numbers to give us that give us negative 9x. So negative 5x, negative 4x, or negative 10x and positive 1x. We want to break it up into 2 pieces. We don't know how. We can't use any 2 numbers. We got to choose the right way to break that number up. The 9x squared is going to stay 9x squared. The plus 2 is going to stay plus 2. But for factoring by grouping, we need 4 terms. So we're going to take that middle term and split it up into 2. Now, the way we decide how exactly to do that, follow these 4 steps on the right side of your screen. So it's called the AC method because the first thing you do is multiply the A by the C. So 9 times 2 equals 18. All right, so that's step 1. Multiply A times C. Sort of box these off. Okay, step 2. Find 2 numbers that multiply to give you the number from step 1. So 2 numbers that give you 18. Well, 18 equals 1 times 18. 18 equals 2 times 9. 18 equals 3 times 6. So we want to find 2 numbers. I'm still on step 2. Find 2 numbers that multiply to give the answer in step 1, which is 18, but also add up to B. The B, I have B in quotations. The B is from the original problem. B is negative 9. So these 2 numbers have to add up to negative 9. None of these add up to negative 9. 1 plus 18 is 19. 2 plus 9 is 11. 3 plus 6 is 9. But, well, we could also make an 18 by saying, well, that's negative 3 times negative 6. That will also give us positive 18. So we stop when we find 2 numbers that multiply to give you 18. They have to multiply together to give you AC, and they have to add up to B. And those are the 2 numbers we have to use. If we want to factor completely, those are the 2 numbers we're looking for to take that middle term and split it up. So now we've got, now we've got 9x squared. Instead of minus 9x, I'll say minus 3x, minus 6x, plus 2. Okay, multiply A times C, find the two numbers that multiply to give you the B, or that multiply to give you AC, but add it to B. Split the two numbers up. Now, sometimes it'll be one positive, one negative. You really never want a negative in the middle. So that second between the 3x and the 6x, if you could avoid that being a minus, you should, but in this case you can't. And then finally, factor by grouping. So now we're 2 slides back to number 3. Now we have a factor by grouping problem. So that's it. We're done. We're done with the AC method, right? The AC method isn't to get your final answer. The AC method is to take a quadratic expression in standard form and split up the middle term to turn it into a factoring by grouping problem. So now step 4, factor by grouping. So we'll take the 9x squared. I'm going to rewrite the problem. 9x squared minus 3x minus 6x plus 2. Group the first two, factor by grouping. Sorry, factor by pulling out a common factor. Right? Ignore the second two. So you look at the first two, factor those separately. Then you group the second two and factor those separately. Now, we have to be careful here. We have to be careful here because watch what happens. I'm going to do this slowly. If we throw parentheses around the last two terms, right? There's got to be something in the middle, a plus or a minus, to separate the parentheses, or else it's multiplication. So if we throw parentheses around there, now in the original problem, that negative sign was only affecting the 6x. Once we threw on the parentheses, now this negative sign is affecting the 6x and the 2. So now we're minusing a 2. That'll give us a negative 2. To balance that off, we have to change that sign to a minus, because now with the parentheses, the minus minus gives us a plus. The minus minus gives us a plus. Right, so this plus sign had to change to a minus sign because of the parentheses. And you don't only see that in quadratic problems we're using the AC method, you see this in grouping problems as well. So now, common factor. First two terms, the 9x squared minus 3x, they both have a 3 in common. They both have an x in common. So there's a 3x within the 9x squared, and there's a 3x within the 3x times 1. All right, now we're left with 3x. And so this 9x squared, we took out a 3x and we're left with a 3x because 3x times 3x is 9x squared. Then there's a minus, and we're left with a 1 because 3x times 1 is equal to 3x. Remember, once we factor, we have to end up with something that if we were to multiply it out, it would give us the line before. Okay, minus 6x and 2. What do they have in common? Well, the x does not appear in both, but they both contain the number 2. 2 is 2 times 1, 6 is 2 times 3. So we could factor out a common 2. So we're left with 3x minus a 1. 3x minus a 1. 2 times 3x is 6x. 2 times 1 is 2. Now it's looking exactly. I'm going to go back a couple of slides. Now this step, what we're at right now, looks exactly like number 2. It looks exactly like number 2. I mean, different numbers, but the exact same structure. So we have first term minus second term. These two terms have something in common. They both contain the 3x minus 1 in parentheses. They both contain that 3x minus 1. So our final answer, it looks like, will be equal to 3x minus 1. 3x minus 1, which is the common factor. And then the leftovers. From the first term, you're left, there's still a 3x left over. From the second term, there's still that minus 2 left over. So 3x minus 1 times 3x minus 2. And you could always check this out. Make sure this is equal to the original problem. Multiply it out, FOIL it out, first times first, outer times outer, inner times inner, last times last. You will get 9x squared minus 9x plus 2. You'll get the original problem. Okay, this is a long video because factoring is a really broad and general and important topic in algebra. Factoring, we do factoring all over the place in many, many different types of problems, many different concepts. Okay, the last type of factoring I want to talk about in this video is special formulas. And I'm only going to do one of the three, but all three work pretty much the same way. There's difference of squares, difference of cubes, sum of cubes. There's three special formulas. I'm going to use difference of squares as the example. So there are these special formulas that are very specific, right? So they only work if your original problem is exactly the right type. So what I'm saying over here on the right, step one, identify. That's the key. Like for factoring, identifying the type of problem you have is really the most important step, because once you know what type of problem it is, you have a step-by-step method for that. So it's that first decision. What type of problem do I have? What type of expression do I have to factor? So if you identify that this problem can be written as a perfect square minus a perfect square. Well, 9 is 3 times 3. That's a perfect square. X squared is a perfect square. That's x times x. A perfect square is equal to anything times itself. So you want to be able, to use this formula, and I'm looking at step 2. So sort of step 1 and 2 are basically one step combined. Can you take the original problem and make it look like this? Something squared minus something squared. So instead of, so for example, I'm going to come over here on the right, 9x squared. Let me use a different color. There's too much blue on the screen. 9x squared is equal to, well, 9 is a perfect square. So that's 3 squared times x squared. And since each of these bases are being raised to the same power, they're both being squared, we could rewrite that as 3x parenthesis squared. That's one of our rules of exponents. And then the second one, the 25y squared. Well, 25 is 5 squared, and y squared is y squared. And again, different bases, but same exponent. So we could write that as 5 times y, all raised to the second power. Right, that's step 2. Right, so there's the first term, 9 times x to the second power. We could rewrite that as 3x in parentheses, all squared. 25y to the second power, we could write 5y in parentheses, and that's squared. And the expression inside the first set of parentheses, we'll call that a. Inside the second, so let me make sure we're specific. The 5y inside the second set of parentheses, we'll call that b. So something squared minus something squared. The first something is the a, the second something is the b, without the squares. And once you've done this, you're pretty much done. This is usually the harder part of the problem. It's the identifying. It's the noticing that this is a difference of squares problem and putting it in the correct form. And once you know that a is 3x and b is the 5y, then we have a formula over here. On the right in step 4, this is our formula for difference of squares. This is to factor. If the original problem is of the form a square minus a square, then the answer is always going to look the same. A minus b times a plus b. A minus b times a plus b. The a and the b in this specific problem, the a is the 3x. So you go to the formula and you replace the a with a 3x, and you replace the b with the 5y. So minus 5y plus 5y. And that would do it. That's our final answer. I mean, once you have everything multiplied together, you have what is called factored form. You just have to make sure you're factored completely. 3x minus 5y doesn't factor any further. 3x plus 5y also doesn't factor any further. Sometimes you'll end up with something that you factored that first step, and then you could still go a bit further by factoring part of that expression again. All right, that does it for this one. This was a long one, but it's also a really important concept, a really important tool that's we're going to be factoring a lot throughout the semester. All right, that's it for now. Take care, everyone.